Hey guys, welcome back to another RASK maths video, and in this video I'm going to be explaining why the sum of interior angles in a polygon is always equal to 180 times n minus 2, where n is the number of sides. So an example of this would be a pentagon. Let's see if I can draw. It doesn't even have to be regular. You can just have any pentagon. And we know the sum of all these angles within the pentagon is going to be equal to, let me just say sum of theta, is equal to 180 n minus 2, so 5 minus 2, which is 180 times 5, which is 540. I guess I'll put a degree sign there. So yeah, that's what this theory, I guess, or fact states, and it lets you work out the number of the interior angle sum of any n polygons. So obviously if it was a regular one, then you can just divide it by n to get the angle of each one if it's a regular polygon. So why is that the case? Well, let me demonstrate using a pentagon, and then we can actually generalize it even further. We can generalize it really easily to any n shape. So let's have a pentagon here, and what you need to notice is that if we put a dot at the center, we can add n triangles. So we can put in triangles to each of the vertex. So we can make a triangle from each vertex to the center and then back to the next vertex. So for n sides, this lets us make n interior triangles. Alright, that's pretty easy. Now, what we know is the sum of all angles within a triangle is always equal to 180. And that's just a fact we have to know. That can be proved other ways. For example, if we have parallel lines and we have some of these angles. So this angle is going to be equal to this angle by alternate angles. This angle is going to be equal to this angle. And remember, these two are the other angles of a triangle. And this is the third angle of a triangle. Angles on a straight line add up to 180, so therefore these angles add up to 180, so therefore angles in a triangle add up to 180. That's a quick way of proving why angles in a triangle add up to 180. And you can see each of these mini triangles is going to have a total of 180 degrees. So that includes all of the interior angles of a polygon as well as these angles in the center. So that tells us that the sum of angles is equal to n multiplied by 180, the total number of triangles multiplied by 180. And then if we just want the interior angles of a polygon, we need to subtract the center angles. And luckily for us, these are always going to form a perfect circle. So the sum of the angles here is always going to be 360. So then you can just factor out the 180, and you'll get n minus 2, like so. And that's why the sum of interior angles is always 180 n minus 2. It's a pretty easy proof, actually. And you can do a similar one if you want to prove why exterior angle is always 360 over n. Yeah, you can see as n goes to infinity, exterior angle gets smaller and smaller, and there's pretty similar proofs to show that, so that might be a future video. But yeah, that was why is the sum of interior angles always 180 n minus 2. Thanks for watching, and I'll see you guys in a future tutorial. Bye.